What is linear? In this video, we are going to talk about the dot product. The dot product is also known as the inner product. The dot product or the inner product of two vectors is the sum of the products of their corresponding components. So for example, let's assume that we have a vector. This is vector A, and then it goes in this direction, and we also have this vector B, which comes in this direction, and the angle between vector A and vector B is theta degrees. Then the formula for finding the dot product of A and B is A dot B, which is vector A dot vector B, is equal to magnitude of vector A times the magnitude of vector B cos the angle between vector A and vector B. This is so because in order to multiply two vectors, you can multiply the magnitude of those vectors. However, two vectors must be in the same direction for you to multiply them. So this cos theta is making up for the direction of the two vectors. For example, when two vectors are at right angles, or when two vectors are perpendicular to each other, then their dot product, which is A dot B, is equal to 0. So that is the reason for the cos theta, which is associated with the multiplication of these two vectors under dot product. The multiplication of vectors comes in two forms. We have the dot product, which is also known as the inner product, and we also have the vector product. Anytime you find the dot product of two vectors, you will get a scalar quantity. What is the dot product of, let's say we have a vector A that has magnitude of vector A is equal to 6, and we also have another vector B that has magnitude of 7, and then the angle between vector A and vector B is 60 degrees. What is the dot product of vector A and vector B? So using this formula, vector A dot vector B is equal to magnitude of vector A times the magnitude of vector B, then cos the angle between vector A and vector B. So this is equal to the magnitude of vector A is 6, then times the magnitude of vector B is 7, then cos the angle between vector A and B is 60 degrees. So 6 times 7 is 42. Then cos 60 is 0.5, and 42 times 0.5 is 21. So this implies that the dot product of vector A and vector B is 21. Now let's also do this example. If we have a vector, let's say vector A is equal to 5i minus 4j, and we have vector B as 7i plus 8j, and we have vector C as 3i minus 2j. Find vector A dot vector B. So how do you do A dot B? This is equal to A is 5i minus 4j, then dot B is 7i plus 8j. So this is equal to What you do is that you will multiply the correspondence. So there's I here and there's I here. So you multiply the coefficients of the unit vector I. So for the I part, it becomes 5 times 7. Then plus the j part is minus 4 times 8. So this is equal to 5 times 7 is 35. Then minus 4 times 8 is minus 32. And 35 minus 32 is 3. So vector A dot vector B is 3. Let's find vector A dot vector C. So just like we did in the first part, A is 5i minus 4j, and then vector B is 3i minus 2j. So this is equal to, in one bracket, we will have 5 dot 3. So we multiply the correspondent, 5 times 3, then plus into bracket minus 4 times minus 2. So 5 times 3 is 15. Then minus 4 times minus 2 is equal to 8. So plus 8. And 15 plus 8 is 23. So, having found A dot B, what if we were told to evaluate, let's do that here. What if we were told to evaluate vector A dot into bracket vector B? Okay, let me write it well. Vector A dot into bracket vector B plus vector C. So what we must note is that dot products are associative, they are also commutative, and they are distributive. So the dot product of vector A and then into bracket B plus C is A vector A dot vector B plus vector A dot vector C. So this is equal to, what is A dot B? A dot B is what we did. We got that as 3 plus A dot C. A dot C2 is what we got as 23. So at the end of the day, A dot into bracket B plus C is 3 plus 23, which is equal to 26. So at this point, let's talk about the sine and the cosine rules. So let's assume that we have a triangle of this form. So let's take this triangle, use this triangle as a case study. And the triangle, we have vector, we have angle A here, angle B here, and then the top part is angle C. And then let's assume that the height of this triangle is h, such that the length from this point to this point is c, and then the length of this side of the triangle is b, and then the length of this triangle, of this side of the triangle, is a. And let's also assume that at this point, the distance between this point and this point is x. So if the distance between this point and this point is x, it implies that the distance between this point and this point is c minus x. So let's use this ideal situation to prove both the sine and then the cosine rules. So let's find sine A. Remember the SOHCAHTOA. SOHCAHTOA. So we are using sine. Sine is opposite over hypotenuse. So in this case, our 90 degrees is here. So sine A is equal to the opposite. Opposite is h. over the hypotenuse, and the hypotenuse in this case is B. So if you multiply both sides by B, so here times B, and this side too by B, this B and this B will cancel. So we see that H is equal to B sine A. So let's label this as our equation 1. Now let's also find sine B. What is sine B? Sine B. Sine B is equal to, so sine B, opposite. The opposite is H. And then over the hypotenuse. The hypotenuse in this case is A. So it is H over A. So if we multiply both sides by A and this side too by A, this A and A will cancel out. So at the end of the day, H is equal to A sine B. So let's label this. This is our equation 2. So this is our equation 2. Now let's equate equation 1 to equation 2. Our equation 1 is H equals B sine A. So let's equate B sine A to the equation 2, which is A sine B. So B sine A sine B. Let's first divide this throughout by A. So we divide this side by A, and we also divide this side by A. So this A and this A cancels. So we can see that sine B is equal to B sine A over A. Having gotten this, let's then multiply both sides by 1 over B. So let's multiply this side by 1 over B, and also multiply this side by 1 over B. So you see that this B and this B will cancel out. So 1 over B times sine B is the same as sine into bracket B over B, which is equal to sine A over A. So this is what is known as the sine rule. So sine B over B is equal to sine A over A. What is sine B? This is sine B over B. So sine B over B is this angle and then this length. So the length divided by the sine of the angle facing the length is equal to sine A over A. A is this angle, and the angle facing A, capital A, is small a. So the length A divided by, the sine of the angle A divided by the length A. So making deductive reasoning, you can see that the sine of an angle divided by the length facing it on one side is equal to the sine of this angle B divided by the length facing it, which is small b. So it also means that we can say by deductive reasoning, we can say this is equal to sine capital C over small c, which is this sine, the sine of this angle divided by the length facing it. So let's continue. So we've been able to prove the sine rule. Let's use the same preamble to prove the cosine rule. So you see that this triangle has been divided into two right angles triangle, which is this side is a right angle triangle, and this side is also a right angle triangle. So what is the magnitude of B and then the magnitude of A? So by using sine rules, we'll be able to find A with reference to C and H. So since it is a right angle triangle, then it implies that b squared is equal to h squared plus, which is h squared plus the square of this side of the length, which is c minus x squared. So b squared is equal to h squared. Then let's expand this part, which is plus c squared minus 2 times c times x, then plus x squared. So this is our equation 1. Now let's find a squared. A squared is equal to the square of x, which is x squared plus h squared. In other words, a squared is equal to x squared plus, a squared is equal to h squared plus x squared. So this is equation 2. Let's subtract equation 1 from equation 2. In other words, equation 2 minus equation 1. So this is equal to a squared, then minus b squared, then plus h squared is equal to, let me start again. So let me do it here. So equation 2 minus equation 1, we have a squared minus b squared is equal to h squared, this h squared minus this h squared, so minus h squared, then plus x squared, then minus c squared, then minus 2cx, then plus x squared. So a squared minus b squared is equal to a squared minus h squared is 0. So we are left with x squared minus 1 times c squared is minus c squared. Then minus 1 times minus 2cx becomes plus 2cx. Then minus 1 times x squared becomes minus x squared. So you see that plus x squared and minus x squared can also cancel. So at the end of the day, we see that a squared minus b squared is equal to, let me write this first, which is 2cx minus c squared. Let's find cos b. What is cos b? Cos b is equal to, cos is using SOHCAHTOA. So cos is adjacent over hypotenuse. So cos b is adjacent, which is x, over hypotenuse, and the hypotenuse is a. So making the x the subject, we see that x is equal to a cos b. So that means that we can replace this x with a cos b, and therefore this implies that a squared minus b squared is equal to 2c a cos b. Let me continue from here. Let's make b squared the subject. So I'm taking b squared to this side and bringing these two terms to the left hand side. So b squared is equal to a squared, then this minus c squared becomes plus c squared. Then when this crosses the equal sign to the left, it becomes minus, so minus 2c a cos b. What does this mean? You see where b is, b squared is equal to a squared, this length, plus C squared minus 2 times C times A, then cos the angle between A and then C. So this B is the angle directly opposite this length B. So you can see that it follows a pattern. For example, if we take A, using deductive reasoning, what will be A squared? A squared is equal to the square of the other two sides, so which is B squared plus C squared minus 2 times the length of B times C cos what angle? You see that in the first case, B is the angle facing this line B. So in this case too, we are going to use the angle facing this length A, and that is capital A. So you can pause the video at this point and try and write the equation for C squared. So C squared is equal to the square of the other two lengths, which is B squared plus A squared, then minus 2 times the magnitude of the other the product of the magnitude of the other two sides, which is 2 times B times A cos the angle that is facing C, and the angle that is facing C is this angle capital C, so cos C. So these three equations defines is what we know as the cosine rule. So the cosine rule helps in the instance where you have the length of two vectors and then at least an angle and the angle between them is known. You can find the length of the other side. And then the sine rule is when you have two angles and then only one length is known. A with coordinates 1, 2, and B with coordinates 3, 5, and C with coordinates 3, minus 6, and D with coordinates x, y are the vertices of the parallelogram ABCD. Find the values of x and y. Hence, find correct to the nearest degree the angle between AD and BC. So since it's a parallelogram, let's draw a parallelogram. So a parallelogram looks like this. So this is our parallelogram. So it is A, B, C, and then D. The coordinates of A are 1, 2, and the coordinates of B are 3, 5. The coordinates of C are 3, minus 6, and the coordinates of D are x and y. Now the question is saying that we should find the value of x and y. So we need to find the coordinates x and y. But since it is a parallelogram, the vector AB is equal to this vector DC, and also the vector AD is equal to the vector BC. These are the special properties of this parallelogram. They are equal because they are parallel vectors. Parallel vectors have equal gradients. So, what is the vector AB? The vector AB is OB, that is the position vector of B, minus OA, position vector of A. The vector DC is the position vector of C, OC, minus position vector of D, which is OD. So since vector AB is equal to vector DC, it means we can equate these two. So this implies that OB minus OA is equal to OC minus OD. So let's make OD the subject. So OD is equal to OC vector OC, position vector OC, minus position vector OB, then plus position vector OA. So OD is equal to, we were given the value of OC. OC is 3 minus 6. So 3 minus 6 minus OB. OB is position vector, which is 3 and 5. Then plus OA. So plus OA is 1 and 2. 1 and 2. So OD is equal to, let's write this as a single column vector. That will be 3 minus 3 plus 1. And then minus 6 plus 5 plus 2. So OD is equal to 3 minus 3 is 0 plus 1 becomes 1. And then minus 6 plus 5 is minus 3. So there's a mistake here. This is minus, so this plus 5 is minus 5. So let's correct this mistake. It's not plus 5 because there's a minus sign here. So it becomes minus 6 minus 5 plus 2. Minus 6 minus 5 is minus 11. Minus 11 plus 2 is minus 9. And therefore, the coordinates of D, which is dxy, is equal to 1 and minus 9. The second part of the question says that we should find correct to the nearest degree the angle between AD, and then BC. Sorry, there's a mistake here. This place is not B, but rather DC. So we are supposed to find the angle between AD and then DC. So what is this angle? It is this angle. This is the angle between AD and then DC. So let's say that angle is beta. So let me divide this into 2. So AD then DC is the same as AC. So in other words, AC vector, let me start from here. Vector AC is equal to AD, which is this vector AD, then plus the vector DC, so plus DC. That is AC. So to find AC is equal to AD plus DC. And therefore to find magnitude of AC, it is the same as magnitude of AD plus DC. That is this magnitude. AC squared is equal to the square of the sum of the other two lengths, so which is AD squared, magnitude of AD squared, then plus magnitude of DC squared, then plus 2 times magnitude of AD, then magnitude of DC cos the angle between AD and DC, which is beta. But we've already established that magnitude of AC is equal to magnitude of AD plus DC. So magnitude of AD plus DC is equal to magnitude of AD squared plus magnitude of DC squared plus 2 times into brackets magnitude of AD. So these are vectors, vector AD. So let me bring the vector sign. then times vector DC, then cos the angle between them, which is beta. So what is AD? Let's find AD, vector AD. Vector AD is equal to position vector OD minus OA. So vector AD is equal to position vector OD is 1 minus 9, then minus position vector A, which is 1, 2. And this is equal to 1 minus 1 is 0. Minus 9 minus 2 is minus 11. So this is the position vector AD. Now let's find magnitude of AD. Magnitude of vector AD is equal to square root of 0 squared plus minus 11 squared. And this is equal to 11 units. Now, let's also find vector DC. Vector DC is equal to OC minus position vector OD. What is OC? OC is 3 minus 6 minus OD. OD is 1 minus 9. And this is equal to 3 minus 1 is 2. And then minus 6 minus 9 is the same as minus 6 plus 9, which is 3. So vector DC is 2 and 3. So let's find magnitude of DC, vector DC. That is equal to square root of 2 squared plus 3 squared. And this is equal to, so we know the magnitude of AD. We also know magnitude of DC. We are left with finding the magnitude of AC. However, we said magnitude of AC, vector AC, is the magnitude of vector AD plus DC. So let's find AD, vector AD plus vector DC. It's equal to, we found vector AD as 0 minus 11. Then we found vector DC as 2 and 3. So if we add both, this is equal to 0 plus 2 is 2. Minus 11 plus 3 is minus 8. So 2 and minus 8. And then vector AD plus vector DC, we got as 2 and minus 8. What is the magnitude of vector AD plus vector DC? It's equal to the square root of 2 squared plus minus 8 squared. And that is equal to square root of 68. We've already established that the magnitude of vector AD is equal to 11. And then the magnitude of vector DC is equal to square root of 13. So to find the angle between AD and DC, we said according to the quotient rule, AD plus DC, magnitude of AD plus vector DC, is equal to magnitude of vector AD and plus magnitude of vector DC, the squared here, sorry. So AD squared plus DC squared plus 2 times magnitude of AD times magnitude of DC cos the angle between them, which is beta. So let's go ahead and substitute the values. Magnitude of vector AD plus AC is square root of 68. So, sorry, there is a square here. So square root of 68 squared is equal to magnitude of vector AD is 11, so 11 squared, then plus magnitude of vector BC is square root of 13 squared plus 2 times magnitude of vector AD is 11 times magnitude of vector DC, which is square root of 13, then cos the angle between them, which is cos beta. So root 68 squared is 68 equals to 11 squared is 121. Then root 13 squared is plus 13. Then plus 11 times 2 is 22 times root 13 is 22 root 13 cos the angle, which is cos beta. So 68 is equal to 121 plus 13 is 134 plus 22 root 13 cos beta. So let's make cos beta the subject. So cos beta is equal to 68 minus 134 divided by 22 root 13. So cos beta is equal to 68 minus 134 is minus 66 divided by 22 root 13 is 79.322. So cos beta is equal to minus 66 over 79.322 is minus 0.8321. So beta is equal to cos inverse of minus 0.8321. Therefore, beta is equal to 146 degrees.